Seems like, yet again, just like Rick, I was the one to pull the short straw and get one of the sessions right after lunch. Welcome, everyone, to Visual Studio plus Docker plus sprinkles of Azure equals modern microservices. My name is Alex. I originally come from Romania, or more specifically from Transylvania, which is most likely another way of saying that whenever I don't do consulting and trainings and write books and things like that, I hunt down vampires. Which, of course, is not true. Now, this will be a very packed session. There will be a lot of different topics I will talk about. And honestly, guys, I have no idea who you are, but here's 2 hints. Number 1, I do suspect that most of you are developers, and that's awesome. You can be one of the brainy guys from the A team. You can do the heavy lifting and do support. That's also okay for the session. You can be one of the IT guys. That's also good. Just like, I don't know, maybe MacGyver if you don't like A-Team, or you can be one of the project managers or team leaders or anything like that, and you want to learn more. Maybe you do architecture. That's also okay. That's also fine. This session will be for you. Now, we did talk a lot throughout the last 2 or 3 years or so about containerization and modernization and Docker and this and that. Why do we do that? Well, number 1, if you think about most of the traditional applications, I'd rather use the term traditional rather than monolithic, because monolithic somehow feels like a bad word. Traditional still means the same thing. So all the traditional applications end up being one of those N-tier, free-tier kind of apps where you have a web application, an API app, and maybe a database layer. But truth be told, many customers I have encountered so far have all the layers on a single machine. So all of a sudden, you end up having one machine which runs your web server, your data feed service, your message queue, your web API, and so on and so forth. And the problems here are obvious. Server patching means application downtime. Each server has the full stack of the application, so whenever you want to do something with the app, you have to take down the app, meaning an upgrade, for example, means you have application downtime again. Now, on top of that, hardware utilization is completely nonsense. Remember all the talks about monitoring and taking right actions based on the measurements you're doing? If you have everything on a single machine, just looking at the CPU or the memory level means nothing. Maybe the SQL Server is using too much memory, because it usually does that. Maybe the application is using too much CPU. You will never actually know where the problem relies at. And then again, there's absolutely no way to individually scale a single component. Now, how many of you have ever used Docker? How many of you have heard about Docker? Okay, how many of you are using Docker in production? That's usually the same answer I always get. And for the past 3 years, it keeps on being the same answer. And I'm quite surprised. And I'll tell you what. In my opinion, Docker is exactly like teenage sex. To be very honest here, everybody has heard about Docker. Some people claim they do it. Almost nobody does it right. And that's exactly the same thing with Docker as well. If you want to really understand what Docker is, the way I usually do a comparison with the virtualization world is that the virtualization has helped us solve the capacity problem. On one hardware, on one infrastructure, you end up having more machines. That's what virtualization does. But the problem with virtualization is that you end up copying binaries of the operating system and allocate memory for the operating system over and over and over and over again. Maybe you have 5 VMs running on one hardware machine. That if all the 5 VMs are running the same edition of Windows Server 2012 or 2016, you're allocating the same amount of data for more or less the same thing. Now with containerization, however, you're sharing the kernel, so that literally means that you're no longer allocating memory for the operating system because it's the one unique operating system. But you still get isolation, which you're interested in. So in a way, you could think of containerization, at least in my opinion, about just like you would say that you virtualize your operating system. And you bring your apps and your data and any other volumes on top of that for your application to run. Now, I'll start out with my first demo. How many of you have ever done any Hello World Docker stuff here in the room? Okay, now for the rest of you, this might be a bit advanced. Don't worry about it, because I will explain everything. Also, do make notice that everything I will show you will be on my GitHub repo, so you can redo this whenever you want. There's a bunch of prerequisites as well, so no worries about that. The first command I will run is this one, which basically says docker run -d -p. The capital P basically stands for whatever ports are defined inside the Docker image, inside the Docker file, based on the Docker file, I will want those to be allocated and mapped to one of the ports in my network stack on my host. So if I just F8 here in Visual Studio Command, this will spin up my container. So what I could do now is just inside the terminal say something like Docker PS, which lists out all the different containers I have. And this is the container I just created. And it's called randomly stupefied Heirovsky. You would say, why is this random? This is a very fun story. So Docker, what they do when you spin up a container and don't specify an explicit name, they will choose a random adjective from a dictionary of adjectives and the random name of a scientist. So you end up having something like drunk Gates or crazy Einstein and things like that. And those are always fun. Now the second thing I will do here is again, run the same command, docker run, -d standing for demonize. That means that it runs in the background. I don't have to block basically my terminal to see what the process is doing. And then -p, which says that I will explicitly specify which the ports I will map are. And this 5000 stands for the Python application which runs on a web server in a Linux distribution running here on my Windows machine. So if I just F8 this guy, I'm exposing port 80 on my machine for the port 5000 for the app. So if I just open up a new web browser, Chrome, for example, I can just do localhost, and this will be my Hello World application running inside Python. It's that easy. And it's just crazily easy. If I just do, I will delete this. This ends up being actually the name of the container. So if I do the Docker PS again, I see the Hungry Franklin. This is what I hit earlier. So just paste in this guy over here, F8 again, and I get the logs from my web server. So if I just refresh again, do an F8 one more time, I should normally see two headers here, which both stand for that. So I can do monitoring as well on top of my machine and so on and so forth. There is a -f parameter, which basically allows me, oh, sorry, I shouldn't have done that, which basically allows me to get the logs on the fly, so my terminal keeps on listening, and no matter how many refreshes I do and I click a few times, I get all the data in real time. Okay, that's awesome. Now, let's go on. The next thing I want to show you is that I will run an Nginx web server. Now, Martin yesterday mentioned Nginx as being a very cool, lightweight web server, and I agree with that. But honestly, even though it's lightweight, I don't want to install it in my machine. I like to keep my machine clean. Even my desktop, it's always very clean. So if I F8 this guy, there you go, that's it. And now if I open up the 81 port, which was mapped to my Nginx web server, I have Nginx running. It's that easy. It's like mind-blowing fast and super easy. And you can do the same thing, for example, with SQL Server. Just imagine the situation where you don't have to install SQL Server on your machine, and within seconds you have SQL Server running. How many of you have ever installed SQL Server, top to bottom? Okay, everybody. How many of you got it right from the first time? Ever first time? Yeah, exactly the same thing. One of the many big errors people especially do at the beginning when they install SQL Server is they forget to add the current user as an admin account. And guess what? They finish installing SQL Server, half an hour later, surprise, surprise, you can't log in. It's a fun story. Now, I'll go a bit further. So if I do a Docker PS again, you'll see me running all those 3 different containers here. And now I want to use some of this PowerShell syntactic sugar. Now I know you guys are developers, so PowerShell is probably not your big favorite thing, but let me explain this. Whenever you see, whenever you see the $, it basically refers to a variable in PowerShell. If it hasn't been used before, it's also a declaration and an initialization in the same time. So here I'm just running through a loop within the for command, and I'm saying from 0 up to lower than 21, I++, and it basically runs this command over and over again. Now what do you reckon this thing will do? Anyone? Come on. I don't have loads of time because I only have 45 minutes, so please. What do you think this guy will do? It will spin up the application 20 times. So I'll have 20 instances of my application just like that. So if I F8 this thing, you see the application instances being created one by one by one by one. And I'm just using one terminal. Had I used 5 terminals, I could do this from 5 different terminals, and I will have all those applications spinned up just like that. And this is, if you ask me, this will eventually change the way we do IT, because no longer right-click publish or run a build definition or things like that. Our build definitions, in my opinion, will eventually only spin up containers because they're so fast. And now if I do a Docker PS again, you'll see all those containers running and listening on the network stack and all running in parallel. And that's pretty cool. I could use some PowerShell syntactic sugar again and do something like docker stop. And here's a cool thing. So docker ps shows me all the containers. Docker ps minus q shows me the containers in a quiet mode. What does that mean? It basically means that I only get the ID, the unique ID, the SHA ID of the container. So rather than getting all the full name, I can save this as an array and a variable. So this does the $sign here in PowerShell, right? And if I do a docker stop from the docker CLI and pass in an array, it basically stops everything from a single command. So I just run this, F8, and there you go. It will stop everything. I could just as well do a docker rm that will remove everything. And eventually, I want to do a Docker pull. So here are some Docker basics again. When you install Docker Engine for Windows, or Docker for Windows, or Docker on Windows Server or anything, you'll get something called an image store. That is your local image store where the Docker images are kept. When you do a Docker run like I did earlier with the training web app, Docker basically checks my local image store to verify if I have the container the image installed locally. And if it is not there, it will pull it. Just like in GitHub, for example, it will pull it from a repository. That repository is called the Docker Hub, the Docker Registry Hub. But it can be other repositories as well. Docker Registry Hub, by default, is a public one. If you pay Docker, the company, then you can also have private ones. Now, that's cool. I will pull now Docker pull Mang catweb. Mang is basically my short name and is the repository inside Docker. I didn't specify another repository, so it takes it from there. Obviously, I didn't trust the Wi-Fi, so I already have it running, and it's up to date with the latest tag. This is just like in Git. It's the Git terminology here. So if I do now a docker run -d -p 85000, I'm running a Python application on top of the Nginx web server inside the Linux kernel on my Windows machine, which has a web application there. So if I just refresh to my local host port 80, I get the randomly generated meme, or GIF actually, of cat. So I can do this again, and there you go. This is my cool cat demo. Any questions so far? I love taking questions, but there is only so much time. So if there are any questions so far, I'd be happy to take them. Okay, let's move on then. Now, what did we do so far? So first, we stored the image locally, and we ran the image locally. That's cool for development scenarios. But what's next? Well, we have to run the image somewhere in production. And for it to be runnable in production, we want to store it somewhere. Now, on one hand, we could store it, like I said, in Docker Hub, in the Registry Hub, but that means that the image would be available publicly to everyone. Maybe I want to make it private. Azure has something for that. The first thing I will show you, and then I will run the application as well. The first thing I will show you, and this is my second demo over here, is that I will have to log in with the Azure command line CLI. You've seen the Azure CLI yesterday at some of the other sessions from my esteemed fellow speakers as well. So if I do an AZ login, this basically logs in my Azure CLI, and this is called the device login mechanism. This is available in AAD for quite some time, and what it does, it basically tells me, hey, you have to click this website. I open up this website, and you have to type in a uniquely generated code. So if I just paste this guy over here, type in the code, and approve that I want the Azure command line interface to be logged in, I would log in with my credentials over here, and now I'm signed in. I can close this web page with this web tab, this browser tab, and eventually it will show me that, hey, you're logged in, and here are all the subscriptions you have. I had to do this. I couldn't do it beforehand because sometimes your session does expire, and my computer did get into sleep mode. Now, normally in Azure, any Azure world, you would now provision a resource group. The resource group is the definition of everything in Azure. Everything starts with a subscription, and beneath the subscription is the resource group. And yesterday at Rick's session about ARM, he has very nicely explained everything about that. Now, I already created that. I'm not going to create a new resource group. It just takes time because I will also have to create an ACR, and this stands for Azure Container Registry. It's very similar to your Docker Hub registry. It's basically where you store your Docker images. I will not create that either. It's already created, and it's almost empty. Now, the next thing I will do here, and this is quite interesting, is that I will say AZ, so Azure Command Line Interface, ACR, Azure Container Registry, login. This is basically a command which tells the Azure service to use the Docker API to log in my Docker CLI on my machine, so my Docker CLI can communicate with that registry hub. So the moment I do that, and I already pasted in my password from there, I will show that in a second, it will log in my ACR. So now if I will just show everything I have, the login server from my ACR, login succeeded, I will F8 this command now. It will just show me the correct login URL. It's basically a fully qualified domain for that login server. Now, let me explain this command a bit. Almost any Azure CLI command which has an output will have this query parameter, almost any. Now, this query parameter basically takes some information from the output, and then it can output it either as a one line or as a table or whatever you tell it to output. Now, next, I will use the Docker tag. Now, this tag command basically specifies that I will apply a different tag rather than the default latest tag, and that will be igloo for the IglooConf, applied to the catweb container image you saw earlier, and I will apply it because I prefixed this with my login server, IglooConf registry.azurecr.io. I will tag it specifically for that Azure Container Registry. So I F8 this guy, and now the image is tagged. So if I just look through all the images I have locally, you will see here I have a bunch of those, but there is one which was just created now based on a 17-month-old image, original image, with the tag igloo. So this is what I'm interested in. So now if I do a Docker push, very similar to Git again, I'll just F8 this guy. This will start pushing my image up in the Azure Container Registry. And it's based on the layer technology. I will not cover that, but I do have some video recordings online explaining what layering is. It's a very cool technology. And because parts of the similarities already existed inside my Azure Container Registry, I don't have to wait for God knows how many minutes for that to spin up. So now that my image is there, I will have only to make sure that the image actually exists inside my Azure Container Registry. So I'll take repository list, and I will show all the repositories. Again, I'm using that output parameter to show everything as a table. This wingtip types was earlier pushed by myself, and the catweb image is there. Now, I'll be honest with you guys, and I will tell you that I did push catweb before, but I didn't use the igloo tag. I used another tag. And just to just to prove that, I'll use the Azure ACR repository show tags command now, and I will show inside the table all the different tags I have for my catweb image, and that's igloo and production, prod, okay? So far so good. Now, what I'm gonna do next, what was the login server? It was this guy. It was something IglooConf registry Azure CRIO. And the reason for why I need that is for one of the following commands. But for that commands, when I will create a new container, basically a compute role to run the container inside Azure, I'll need a password. And I'm using this crazy command over here. Now you might be wondering, how the heck do I have to remember all of that? Because this is so difficult. But to be fairly honest, this is actually plain JSON, and the query command does nothing else than query JSON. So if I just show all the credential values from my not CloudBrew, this should have been IglooConf. My bad here. CloudBrew is another very cool conference. So if I just do this thing, and I'll paste it over here again. So if I just do F8 over here, I will show a JSON value, and out of the JSON value, I will only want to take the value of the first password. There are always two passwords so that you can recycle your passwords. The first password is one I want to retrieve, so I can just say query password 0, so the first iteration from the array, dot value. And that will show me only the specific password out of that. Now, why did I need that? Because now I want to create a container. When you see AZ container, this basically invokes the Azure Container Instances, another cool service from Azure. And this will create a container instance inside a container group. And I'll explain container groups in a second. So I just do this command, and they're basically specifying, hey, I want 1 CPU core, and I want 1 gig of memory, and here's the password, and I want to have a public IP address as well, and I will expose port 5000, and now, if I look at what the IP address is again, I will have my application running up in the cloud. And honestly, the only command which is actually something you as a developer would do over and over again whenever you want to spin up a new container is this last one, AZ container create, and that's it. Because all of the other commands I had so far were basically configuring my CLI, and you can script that out, you can save it as a script file, and so on and so forth. So now I just have to wait for my first initialization, and yeah, there we go. So if I zoom in, you see I have a publicly accessible IP address listening to port 5000 and showing me the GIF. So I can refresh this guy over and over again, and of course I can get logs and so on and so forth. So this is cool. Good. Now, why was this important in the first place? If you think about it, even though the whole concept of containerization in Docker is to make sure that what is the one thing any developer says on a daily basis? It works on my machine. Exactly. That is what we want to get rid of. We want to get rid of the world where every single developer says it works on my machine. And Docker is very cool for that, because all of a sudden, everything runs inside a container, and everything is configured similar to a desired state configuration because of the Docker configuration file, of the Docker file. But you still have to install a very lightweight Docker engine, and that still has to be configured. The idea of a Docker container instance is very simple. Rather than install stuff locally, make sure that it runs inside the cloud, and that's it. Now, inside a container registry where you store your image, you have those repositories with the list, with the tags and everything, and then you can run your containers. And the containers can run inside a container instance, like I showed you, but, and here's a very big but, it is one instance. So I would basically suggest at this point that it's only useful and very useful, especially for development scenarios, for testing scenarios. There is another cool thing you could do. So now let me just take you really quickly back to my Azure portal. And what I will do here is I will go to my IglooConf container service, and I will add a new web app on containers. So I'll just search for that in the marketplace. Click here, click create. Nicely done. And now I'll just choose whatever crazy name. Let's see, IglooConf, whether that's available or not. No, it's not available. Let's append a 0. Yeah, 0 is good. And now I will also choose my application service plan. I'll create one because it's very fast to be created. Come on. I always love it when people complain about taking roughly a minute or so to spin up a web application. Compared to the fact that a few years ago it would take us 3 months to get a shiny new web server, 1 minute is nothing, right? But people still complain about that. IglooConf app service plan is a very good name. Click OK. There we go, and configure container. And this is where the magic happens. Basically, now I will only specify, hey, I want to run the container image based on the IglooConf registry. I will choose my image to be the cat web, and I'll choose the igloo tag I created earlier and I pushed earlier from my machine. So if I click create, roughly within a few seconds, I will have my application up and running in the cloud. And the cool part about that web app on containers is that, remember, this was a Python app, and it exposed port 5000 based on all the definitions and images and files and so on and so forth. Now, web app on containers will look at that, and because it's supposedly going to run a production service, that 5000 port will actually be mapped to my port 80. I can override that behavior if I so would like to, but so just to prove it, it's port 80. Just give it a second, and I will have my application up and running in production. And this is pretty awesome if you ask me. Why? Because just like any other application service and any other web app, I can spin up to multiple instances. And all of a sudden, I have a high availability for my application running in containers. Want to move it somewhere else in AWS? Sure, it's a container. Normally, you should be able to do it. And it's based on Linux. So you don't have any Windows dependencies or Windows Nano or whatever either. So that's pretty awesome. It does take a bit at the first run. It's a dry run, so normally it goes faster, but again, oh yeah, there we go. So we are inside IglooConf 0 Azure websites.net. We can refresh a few times and we get the randomly generated GIF. That's pretty awesome. Good. Now let's move on, because there is so much more stuff to talk about. I did tell you it's a packed session. There is also the concept of Azure Container Service, and this has been around for a few months, actually years already, which basically allow you to use a more production-ready orchestrator, such as Docker Swarm, which isn't really production-ready, but still, or DCOS or Kubernetes. But there is another newer Azure Container Service, which is the AKS rather than ACS. As far as I know, it's still in preview. And this basically exists because now Microsoft is mostly focusing on Kubernetes. Why do they do that? Well, number one, they acquired a company called Dees in 2017, whose co-founder and, as far as I know, CTO, happens to be one of the co-creators of Kubernetes. So now Microsoft actually hired one of the Kubernetes creators, if you think about it. And that guy, Brendan Burns, actually happens to lead the Azure container efforts as well. Now, what a cool part about Azure is that AKS, which is your management orchestrator, blah, blah, blah thing for containers, is completely free. In Google, you have to pay for your orchestration. In Amazon, you have to pay for your orchestration. In Azure, it's free. You only pay for the VM, which is running for those machines. And this is a quote from Microsoft. You can find it on docs.microsoft.com, which basically says, with AKS, you will pay nothing for the management of your Kubernetes cluster ever. Unlike all the other cloud providers, is something like which I add. Now, Service Fabric for the win as well. Why Service Fabric? People have heard about, and Christian had a very good presentation on Service Fabric yesterday. Service Fabric actually can run two more great things. Number one, guest executables. So if you compile your application as an exe file, you can run that exe file as a reliable service inside Service Fabric. But it can also run a container. Why is that important? Because all of a sudden, Service Fabric can be your orchestrator for containers. Let me show you how that would work. And as you know, Service Fabric can run in all the clouds. And now, what I will do an application modernization scenario for this demo. So what does that mean? I will take a very legacy application, and I will run it as a modern application. And I will explain what a modern application is in a second. So let's do that. Back to the demo terminal. Here we are. The application I decided to use yesterday, so this is a bit tricky, is this Wingtip Toys app. This was one of the sample apps created by Microsoft. It's still available on code.microsoft.com. You can find it online. It's available for everybody. And it was lastly updated in 2016, but it was originally created, as far as I remember, 2012. So I downloaded this application. I extracted the zip file, because it's a zip file, and I opened it in Visual Studio just to basically win some time. And the first thing you get, this is a freshly opened instance of the solution, is the fact that, hey, you don't have SQL Server 2012 Express LocalDB installed on my machine. Well, go figure. So I'm okay with that. I will accept that warning, and I'll do some crazy stuff next. And here's what I'm going to do. Number one, I'll open up the Solution Explorer as soon as Visual Studio fully loads. And from here, you will see that I have this WinForms app. Pretty cool WinForms Wingtip Toys app. I will, for the first thing, open up webconfig. Why do I do that? Because this relies on a database. And rather than use localDB, I will replace the localDB connection strings with something more useful, which is Azure SQL database, of course. So I will just delete this guy, and I will delete the second connection string as well. And once I do that, I am ready to paste in my other connection strings for the Azure SQL database. And I got them copied over right here. Okay, so I'll paste this guy, and I'll paste this guy over here again. Now, next thing is obviously just test the application, make sure that it works, because otherwise there's no purpose in modernizing it in the first place. So I will run the application. This is the first time I'm running the application. Remember all the warnings I saw in Visual Studio and this and that. Hopefully it will run. It will have to do some entity framework stuff to create tables and this and that based on the seeds. Come on, please go faster, because there's so much more to talk about. Any questions so far? No questions. Good. We're still waiting. Visual Studio, please be our friend. Go faster. Does anyone have like 2 gigs of RAM to spare? Because apparently I'm going low on my internal memory right now. Come on! I promise you this should work. Because it's Microsoft. It works on my machine. Okay, it's taking too long. And I'm wasting some of your precious time, and I'm sorry about that. There is no debugger. No, there's no debugger. Okay. I mean, no. We have nothing else. We have nothing else to do? You're fine. I'm fine? Okay, good. That's good to know. No pressure. None. Come on! Honestly, this usually goes way faster. I wanted to prove that it's a freshly new app. I think I already successfully did that, but now I cannot prove that it actually works. Pose for the camera. Hey! We have time. So we're halfway there. And the reason for why I'm saying that is because it shows that there's a custom error to show. So obviously the modules did load, but this isn't good. I will still show you what I want to show you. No, I have no idea why this isn't working right now. For whatever reason, it doesn't work. Oh, maybe my IP address changed and it doesn't have any access to that. Let me just double check. So I will go up to, you like this GIF? Yeah, it's a cool one. So let me just quickly go back to my resource groups. I'll open up database resource groups. And here I should have this server. And inside of firewall configurations, let me just add, oh yeah, oh no, it's the same IP address. So this does not help. I have no idea. So here's what I would have done. This is the Web Forms app. I will right-click the Web Forms app, and I will select Add. And the next thing to select here, Visual Studio froze, no, is Docker support. The moment I do that, it basically adds another project to my solution, which is my Docker support project, and that contains a Docker file. Now, because of that, and this is basically the definition based on which Docker image is created. Now, once I did that, I should be able to move my Docker engine for Windows to switch from the Linux containers to Windows containers. It was already on Windows containers. I think Visual Studio does some magic here. You see how fast it is to move from Linux to Windows? Oh yeah. So now if I would run this application, it would open up a different web browser, but rather than running locally and spinning up IIS Express, it would run inside a container based on Windows. And that's pretty cool. Now why is this cool? Because the next step would be to right-click the solution again and add a new project. I think I clicked the F5 button, didn't I? Build, cancel. So what I could do next is click New Project and specify that I want to create a Service Fabric project. And here we go, Service Fabric. Whatever name, doesn't really matter. I will click OK. And I will specify here that I want to create a new reliable service based on containers. And what I'm required to type in here is the container image. So I would just say something like IglooConf.azurecr.io, container registry, that's what CR stands for. And here would be my wingtip toys dot whatever latest tag of that image. And this is the name of the service. I click OK. But now there's some extra things I would normally have to do. And everything is scripted out, so you can take that information from GitHub. Pretty pointless at this point to show you what configurations are there to be done, since I cannot run the application for whatever reason. But the idea is that I would, number one, have to specify here one of the policies, which basically says, hey, you're taking the image from a private repository. Here's the username and the password you have to use. And the other thing is, hey, inside the service manifest, this is an application which exposes whatever ports. I want to publicly expose this endpoint to HTTP, to protocol HTTP, and to port 80. And by doing that, basically I'm telling Service Fabric that it will expose a port whenever it runs this application. And this is super useful because if you think about it now, I get the Service Fabric service healing feature, for example, where I have within a cluster, in this example, 6 different nodes. All of them have evenly balanced within the cluster all the services I've running. One of those services is this container. Whenever one of the service, for example, one of the nodes containing one of the primary instances of my service goes down, Service Fabric will just make sure that it promotes one of the secondaries to a primary. It will recycle that one, the failing node. It will create a blank new node for me. And on that blank new node, it will make sure that it evenly balances out all the different instances of the application I have. So now, besides the fact that I have file availability, I also have disaster recovery within my cluster because I'm running Service Fabric. Now, why is that important? I'm skipping a few slides here. Because when you do application modernization, you want to think about the following steps. Number one, you have your monolithic application. You want to containerize it. Because rather than writing the entire application from scratch as a microservice application, you could just create a container, and you saw a Web Forms application being created within a container and running within a container just now. And besides that, whenever you have a new feature, could create a microservice approach with a reliable service for the new feature. You communicate with the monolithic application, and then all the new features you have for your application, which is still in continuity in your application lifecycle and so on and so forth, is created as a microservice. So now you start gradually to learn microservices, to learn how that works, and to have a microservice approach for your application. And whenever you're ready to take the monolithic core of your 5.0 version of your app, you just decompose it. And decomposition is the latest step of full application modernization. Now, thinking about it, you end up with something like this. something running inside Service Fabric. And this is what I really love Service Fabric for. Just like Christian said yesterday, Service Fabric isn't for everybody. But if you want to microservice your monolithic application without writing it from scratch, I completely believe and strongly believe that the Service Fabric really has a very good advantage here. But there is one more way to do stuff. There is one more way to do it. Service Fabric requires a lot of configuration, and the installation isn't really straightforward. And then maintaining and running the thing has a learning curve. You have to understand what the logs are, what the errors are, and why they might appear. Now, on top of that, serverless. When you end up decomposing all the different services, you actually have a microservice approach where each and every single micro stuff does one thing, is responsible for one thing. And serverless actually does the same thing. Now, if you want to have communication between your microservices, you can do it over remoting, like Christian mentioned yesterday, or you can do it through other means, or you can do it HTTP, or you can use queues, or you can use HTTP, or you can use other means of communication. And serverless can do the same thing as well. So Azure Functions, actually, if you want to write your application from scratch, can be both your orchestrator and your runtime for your microservices. Now, what I get from my experience with Service Fabric, and especially with customers who hear about Service Fabric, about Azure Functions, is that they don't want to do it. Why? Because they don't want to learn a new tool. It feels like there's a learning curve. It feels like it's so difficult. But truth be told, it's not. The difference from running plain old .NET code in whatever framework version you want and developing a function and the application to run as an Azure function is only maybe 5 lines of code, and that's it. Some attributes you have to learn that you have to put in when you define your classes and when you define your methods, and that's it. Actually, I will do a challenge now. I have roughly 10 minutes left. So the challenge is like this. The challenge is I will develop an application from scratch in Azure Functions, and this is very tricky. And I will make it so that whenever I have this is a green button. It's more or less of an IoT button by a company called Flick. And the idea is that I can do whatever I want with it. There is a mobile app. This button communicates over Bluetooth Low Energy with the mobile app. And the mobile app from Flick can do whatever I want. And one of the things I will do is I will invoke event hubs. So whenever I click this button, my expectation is that my customer would click this button. Whenever the button is clicked, I will want a service request for example, like a support case, be created in Salesforce. And on top of that, also post a message in Teams, so the Teams knows about that message. And you know what the difficult part here is? I never worked, ever, with the Salesforce API. And even though I do know that Microsoft Teams is all about Office 365 and Outlook groups and this and that, I never worked with their APIs. So can I do this in under 10 minutes? Well, let's see. It's a challenge, right? So the first thing is that I will close this Visual Studio instance because I require some memory. No kidding. So I will start a timer. Fingers crossed, there we go. I almost have no time. So right click, new item. I did cheat a bit because I do have the Visual Studio instance already opened, and I will just specify, hey, I want to create a new Azure function. And the experience here is very simple. It's just like the wizard online, where I will say that I will create an event hub trigger based, and I will specify here event hub connection. This is basically a name I have earlier configured with the event hub service I have provisioned. So if I just open up the local settings JSON file, you'll see that I have here Event Hub Connection as the name for my connection string. So now, I will just add a breakpoint over here. Let me increase the font a bit. There we go. And I will run the application. This will run the application locally as it emulates the entire behavior it would be up in the cloud. And you get the nice Azure Function logo, and it should be running, and oh no, error, like any other cool app. Why is there an error? Because my Event Hub trigger is listening to a hub which probably doesn't exist. So let me go straight back to my resource groups. I'll open up Azure Functions Clicker. This is the Event Hub I created earlier. Oh, no, not this one. This one is the Event Hub. So if I just look at the hubs, The hub name is IoT button 1. So I just have to type in here IoT button 1. And the Azure function basically does the entire magic of invoking a client for Event Hub and communicating with it and creating the message factories and so on and so forth. So I don't have to learn anything about the best practices of running or invoking Service Bus or Event Hub or whatever. Azure Functions does the magic. So now, as soon as it says web host started or something like that, it has all my functions up and running in the emulator. This is based on something called the Azure Functions CLI. So web host started. Here's the app. Here's the button. I will click it. Hopefully you will read this. You will hear a sound. Okay, there we go. There's the sound. And now, if I do have an internet connection, I have a breakpoint running within my app over here. So that's pretty cool, right? So now what I will do next, because this works, I will just stop everything. And rather than writing to a log, I will read the message. The message comes in through this parameter over here called my event hub message. So I have to deserialize that object. So I'll just say my JSON convert, because everybody uses Newtonsoft, deserialize object. Oh my God, I'm almost out of time. So this is deserialized to a device message. This is an object I have created to deserialize the message, and the data itself, the string, is my event hub message. Good, cool. So I will say that if my message .alert .type is an alert, because remember, I only want to spin up alerts, then I will invoke my logic app to be triggered. This is an asynchronous message, and I require logic app message for that type of parameters. So I will just say logic app message, and this has probably some extra properties over there, such as the device itself, so that I know where the message came from, and this will be from my message.device. And there is another location, so I know where the button was clicked, and this is inside my location property of the message, and then there is a type, which is obviously the alert, but I can also take it from the message type. And because this is asynchronous, but it's inside the static void method, I will have to make it synchronous, so I'll just type in the wait keyword. Not a good practice, don't learn from me. So this is good. Now, as any good developer, I will not test my application on the machine, I will test it in production. So the next thing I have to do here is invoke the logic app I mentioned earlier. I already created this because it takes roughly 2 minutes or so. So I didn't do anything else with it. So I will just click the edit button, and now let's use Salesforce and Microsoft Teams. So the first things first, new step, add an action, search for a connector, Salesforce. There we go, create the record with the second version of the API. Apparently there's a second version. What do I want to do? Well, support cases, I think that's called cases. Cases, yeah, no, not this one. Cases. Okay, status is a new support case, came through the web, subject, oops, problem, and just to basically prove that this is a new one, I'll type in an expression, which is the daytime now in UTC format, priority high, because it's this big problem. Description, please solve this yesterday. And the next step is, sorry? I did say please, so I'm a good customer, right? The next thing is to write a message in Teams. So obviously if you type in Teams, there is no Microsoft product return, so I have to type in Microsoft as well. Microsoft Teams, there we go, post a message, and I will choose, I'm already signed in with the same credentials, so I don't have to do anything here, they're already saved. This is one of the teams I will use with this user account, IoT button. And this says, do I still have time left? Yeah, I still have time left. Plenty of time. And UTC again, just to make sure that I'm not messing stuff up. Good, let's save this guy. Apparently it's saved, so now let's run it in production. I'm not gonna publish it anyway, so I will just click the button. Next, I will open up Salesforce, refresh the web page. There is nothing, hopefully, in the Salesforce cases tab. Yeah, it's completely empty. And I'll open up my Teams channel as well. There we go. And now, if the application is running, it is running, I'll click the button, Going once. Let's do it a few times. Going twice. 3 times. Sounds good. 3 unhappy customers right now. Job host started. These should come in. I'm still on a Wi-Fi connection from my phone, so it does take a while for the for the phone to trigger Event Hubs. But otherwise, Event Hubs is just blazingly fast. And it did run 3 times. So now if I refresh the web page over here in Salesforce, wow, I have actually 4, because one of those clicks was probably in the queue. So there we go. And the message is there. Oops, problem at and UTC time. Let's see Teams. Teams has 4 new messages. So there you have it. And it only took me 7-ish minutes. Pretty cool, isn't it? So I just made it on time. I guess you don't have questions. Thank you, everyone. Here is the feedback survey link. I would love it if you would give me a 5-star rating, obviously. Here's my GitHub repo username. I will post the scripts probably later this afternoon. So again, thanks so much. If you do have questions, I'll be around for the rest of the day. Thank you.